Yeah.
Hello, everybody. Happy day to you. This is Orekoya Olusegun Physics Mathematics Fundamentals on YouTube. I'm your mathematics and physics tutor. I want to be appreciative as regard my subscribers and those people that like my video, that share my video and make comment too. May God bless all of you. Today we are taking a topic in mathematics, and that topic is the continuation of the topic we've done before as regards special series in mathematics. Before, in my last video, we've done what is called polynomial series. We've done what is also called binomial series. I've done what is called Maclaurin and Taylor series. Today, we want to, express certain trigonometric function as in form of series. So we are taking sine function and cosine function. We want to express the cosine and sine function in terms of series using Maclaurin series. Now, please, I want you to pay attention, especially mathematics major and science students. The area of physics, chemistry, and so on and so forth. So now we are taking this topic now, cosine and sine series. I'm starting with cosine. Let's say our function f of variable x, f of x, is cos x. I want to express this in terms of Maclaurin series. According to Maclaurin, this f of x is actually in the form f prime of 0 x raised to power 0 all over 0 factorial plus f of 0, sorry, not f prime of 0. So then f prime of 0 x raised to power 1 all over 1 factorial plus f prime prime of 0 x raised to power 2 all over 2 factorial plus f prime 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 of 0 of x raised to power 3 all over 3 factorial plus f prime 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 of the fourth derivative raised to power iv, that's the fourth derivative of 0 x raised to power 4 all over 4 factorial, then plus the addition continue onto the nth derivative, that is f nth of 0 x raised to power n all over n factorial. So I want you to take note of something. This particular general nth time, the general nth time here, we can use it to generalize Maclaurin series. So this particular Maclaurin series, which is f of x, can be generalized, please take note of that, as summation of this pattern f 0 x raised to power n over n factorial, then the counter start from 0 to infinity. So the highest power is nth power. And take note also, note that the Taylor series, this I call Maclaurin series. Note, Taylor series, which I've indicated in my last video, can be obtained from the Maclaurin series by setting 0 to a and setting the variable x to x minus a. So when we substitute this in this place, then my Taylor series become f of x is equal to summation n is equal to 0 to infinity. Nth derivative of 0, instead of 0 you say of constant a, then this variable x you put x minus a raised to power n divided by n factorial. So you can see the similarity and the difference between Maclaurin series, this Maclaurin series, and this particular Taylor's series. Take note of the two. So but I'm using Maclaurin series now to generate the cosine series. So how do we do that? Before I do that, I want to simplify what I have here already. Zero derivative of a function is a function itself. Please take note of that. The zero derivative of a function is a function itself. So this is f of you can equally still take it as f of 0. So we have f of 0. Then anything raised to power 0 in mass is usually taken as 1. So x raised to power 0 is 1. Then 0 factorial is also 1. So the whole of this known is simply f of 0. Then plus first derivative of this function still remain as it is. Then x raised to power 1, when you take a variable to a power of 1, we normally write the variable without putting the power. 1 factorial is simply 1. Then plus f of 0, x raised to power 2. 2 factorial means 2 times 1, which is same thing as 2 factorial. 2 times 1 is 2. Then plus third derivative of this function of 0, x raised to power 3 over 3 factorial plus f of this one, the fourth derivative, then x raised to power 4 all over 4 factorial plus and so on and so forth. So please, I want you to take note of something. When I say n factorial, as a reminder, you should remember that you are going to be multiplying n in a decreasing order by subtracting 1 until you reach 1. So n factorial means n, then time the next time will be reduced by 1. You say n minus 1, then the one that will follow this will be reduced by 1 again. That will be n minus 1 minus 1, that's n minus 2. Then you continue your multiplication until you reach 1. That's the meaning of n factorial. Please take note of that. Another thing I want to tell you is that when your n, this n factorial can be written as n times n minus 1 factorial. Now when your n is taken as 1, your n is taken as 1, you put 1 anywhere you see n. So 1 factorial is equal to 1 times 1 minus 1 factorial. 1 minus 1 is 0. So 1 times 0 factorial. 1 factorial is 1 times 0 factorial. So that means 1 factorial is taken as 0 factorial. That's the reason why this 0 factorial is 1. I have proved it there. Please take note of that, please. Now, concerning this particular cosine function, cosine function. Sorry about this, my marker. The cosine function. So when our f of x is equal to the cosine function, f of x, when it's equal to cos x, it gives us this. So what we are going to do now is this. Note, in our standard derivative, when your f of x is equal to cos x, f prime of x is actually minus sine x. When your f of x is sine x, f prime of x is cos x. The meaning of f prime of x means the f of x, the x. Please take note of this. We are going to use this idea, to do simplification here. Now, like I said, this particular cos of x, let's say we express it like this. So when your f of x, is equal to cos x, I want to find f prime of x, f prime of x, f prime of x up to, let me stop it at 4. So f prime of x that I'm going to have here, we can say is taken as the cos x, the x. The cos x, the x is going to give us minus sine x. Take note of that. Then f prime of x, where we stop, we are going to differentiate this. Minus 1 is a constant. Take it outside. So it's taken as minus 1 times the sine x divided by the x. And we know that the sine x is cos x. So that means f prime of x is going to be minus because of this sign, minus cos x. Then f prime of x, this constant, take it outside, it's going to be the cos x divided by the x. So it's going to be this minus, the cos x is actually minus sine x. So this becomes positive. That is sine x. That is my f prime of x. So we want to get the fourth one, the fourth derivative. That is the fourth derivative of x its derivative for this, that is the sine x, the x, and the sine x dx is going to give us a cos x. So these particular results that I have obtained, I can list them out now. So I have my f of x to be cos x. My f prime of x is minus sine x, and then my f prime 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 of x is a sine my f of x is cos x, yes. F prime of x is minus sine x, yeah. Then f prime of x is a minus cos x. From this minus sine x, so minus cos x. F prime 1 is minus sine x, then f prime prime is minus cos x. So I'm supposed to be like this. That's if you look at this very well, please, we need to be extremely careful. F of x is cos x. F prime of x is minus sine x. Then f prime of x is, are we supposed to have minus again? Because this is f prime of x minus sine x. F prime of 1 is minus cos x. I'm having cos x minus sine x. Then f prime of x minus cos x. Then f prime of x is a plus cos, is plus a sine x. Then the fourth derivative that we have here is cos x plus cos x. We need to examine our results very well to be sure we are okay. Okay, no problem. Now, we want to get f of 0. F of 0 is when your x is 0. Then f prime of 0 means when your x is 0, f prime of 0, and so on for this function that we have here. So, for the f of 0, you put 0 anywhere you see x here. It's going to be cos 0. And cos 0 in trigonometry is 1. You can press your calculator to confirm. Then for f prime of x, when our x is 0, f prime of 0 will be sine of 0 times minus. Everything will give us a 0. Then f prime of 0, f prime of 0 is going to be minus cos 0. Cos 0 will give us 1. Then f prime of 0, that is to the third derivative. You know, sine 0 will give us 0. So everything will be 0 here too. Then for this place, the fourth derivative of 0 here is cos 0, which gives us a 1. So that means we are going to substitute these answers to what we have here. So that means f of x, which is our original function, which is a cos x, can be expressed in a series form, in this format. Our f of 0, we've taken it to be 1. So you put 1 there. So that is 1. Then f prime of 0. F prime of 0 is 0, so we don't need to write it. Then we move down to this one. F prime of 0. F prime of 0 is minus 1. So what we are going to have here is going to be minus s squared divided by 2 factorial. Then when we move down to f prime of 0, which is 0, that is for the third derivative. So the whole of this place is 0. So we move down to the fourth derivative. And our answer for f, the fourth derivative of 0 is 1. So we move down to this place. It's going to be plus plus s raised to power 4 divided by 4 factorial. So if you look at this pattern, we are moving from negative to positive. That means the next term that we are going to have there will be minus. And you can see this power, we are having even power. So from 2 we move down to 4. That means the next one will be 6 over 6 factorial. Then from negative move down to positive. The next one will be what? S raised to power 8 all over 8 factorial until we get to terminating, we get to infinity, because this particular function is an approximate function for the value of cos of x. So please, I want you to take note of something, that this particular series is an approximate function to the actual function, and this variable x is not measured in degree, it's measured in what is called radian. In one of my videos, I've shown you how to convert angle in degree to angle in radian. Please, you can check one of my videos on that. So this is the expression of a cos function in series form. Once again, please do not forget to like, share, subscribe. Click on the notification button to have more of my video. Have a nice day. Bye.